This is a chemistry rate specified prac. In front of you now on the screen is the method, called the procedure, apparatus that you might need, and a little bit of an overview of how you collect gases to measure rates of reaction. I'm going to show you how this one works and demo the experiment in a minute. However, you could use this setup as well. This one is just slightly more accurate because it actually collects the gas and you're able to measure at smaller intervals. So the first thing we're going to do in this video is watch the prac taking place.
We're going to look through the specified prac now for looking at how concentration changes the rate of acid. So if we just zoom in on our apparatus, please, Seth. We've got two different concentrations of acid. We've got a measuring cylinder so we can keep that volume of acid the same. We've got our marble chips, a conical flask, and then a gas syringe. Now this is something that will come up in a lot of exam questions, and we're going to measure how much gas is being produced. And I've got a table of results here to just record my data. So the first thing I'm going to do is I'm going to put my conical flask on the balance, and I'm going to tear in. How do I tear in something? And I'm going to measure out 5 grams of marble chips. Yeah, I called it 5.
Oh, that was perfect.
That was good, wasn't it? Okay, then, to make sure I'm keeping everything the same, a control variable is going to be the volume of acid. 50?
Yeah.
50? Yeah, we're going to do 50. And I'm going to make sure that I'm down at the level to avoid parallax. I'm making sure that I'm measuring it the same every time. Yeah, so we can see that. See, we're just measuring on the curve by there. And then now, this is where I have to be a bit quick. I've got to put my acid into the conical flask and then quickly bung the top. Oh, so perhaps this could be easier if there was 2 of you. Seems like a 2-man job. Oh, we've got an assistant. So if Miss Hillsden, if you could put it in, and then I'm going to go. And then we're just going to measure the volume of gas is being produced. And as you can see, this line is going to move. We can see it grow now, actually, as gas is being produced from this reaction.
It goes quite quick, doesn't it?
Yeah. Goes quicker than I thought it was going to go, actually. And just to make sure all the reactions are happening, I'm just swilling it just to get them going. See some good science.
Right, what are you going to do once it's done then?
So once it's done then, because we can see now that the volume of gas, I'm just going to say that I've recorded it, it would be 50 centimetres cubed. So I'll do that. And I'm going to wait for the reaction to finish, and then I'm going to start all over again. I'm going to wash my conical flask out just to make sure there's no acid or marble chips in there. I'm going to measure out 5 grams again of my marble chips, and then repeat at 2 molar hydrochloric acid and 3 molar, and then I'm just going to compare. We're going to look through.
So what you would then do once you've got your set of results is draw a table, a graph of your results, which I then plotted here. Concentration would go along the bottom. So you've got different concentrations of acid. The higher the concentration, the more particles there are, remember, and then looking at how much the volume of gas is collected over a period of time. As you can see, it's a curve upwards, so you've got to make sure you describe it. As the concentration increases, volume of gas produced increases at a decreasing rate, so starting to level off. Once it has leveled off, so if I was to add a little bit of extra, once it has leveled off like that, that means that the reaction is finished and you've reached your excess there. Even if you carried on increasing the concentration, you wouldn't see any more volume of gas being produced. That's most probably because all of the marble chips would have reacted. So that's something they might ask you to do, draw a graph and describe the graph. The final thing, well, they can ask you loads of different things, but one of the other things I think they might ask you is to describe why that happened. So why did, as the concentration increased, the volume of gas increase? And I've just given you like a little bit of an overview there. As you increase the concentration, you increase the number of particles in the same area. And I've just drawn a little picture. So if we had 0.5 mole concentration, you'd have that many particles in the same area. If you had 3 molar, you'd have that many. Okay, that's just a diagram. It doesn't mean to be exact. This leads to an increased collision and a greater frequency of successful collisions. Remember, particles are always collided. It's them successful collisions that you want, and hence an increased rate of reactions. They might ask you to describe why that's happening in your graph. They might use the word particle theory. So if you see that word, do not get concerned. You know what it is. You're just essentially writing out that paragraph there. They might ask you to calculate rate, and there's 2 different equations that they can ask you to use. They will give you these equations, so you would essentially just be inputting the numbers. They will give them if they're going to ask you to calculate rate, but that's just an example of something they might give you. And finally, they might ask you to comment on the accuracy. So swirl consistently. This was something that didn't happen in the demo that we just did, but if you are going to swirl, you have to swirl consistently using the same force every time, okay? So to be really accurate, you'd use a piece of machinery that would constantly be swirling for you. If you aren't going to swirl, you don't swirl at all. High resolution equipment, you could get the gas syringe to measure, instead of measuring to centimetres cubed, which is what it measured to, you could get it to measure to millimetres cubed. So it's a higher degree of resolution, making your results more accurate.